Namaskar and welcome back to Aviation Avi, go where you feel the most alive. Welcome to part 2 of the video on radar, where we talk about the implications and usage of radar at an airport, how it is used, what it is used for, and how the radars are protected around the airport. Part 1 of the video on radar talks about what is radar, its types, and its usage in today's modern day and age. If you have not watched part 1 of the video already, we'll provide the link in the description. So without any delay, let's get started with part 2 of the video on radar. Navigation with radar. Navigation is the art of determining the position of an aircraft over the Earth's surface and guiding its progress from one point to another, let's say from point A to B, from its origin to its destination. The art determining the position of the aircraft from its origin to the destination is known as navigation. To accomplish this art, some sorts of aids are required. In early days, voyages were accomplished by navigators with the knowledge of terrain or the movement of the sun, moon, star, understanding how the shadows are formed because of the movement of the sun, the direction of wind flow, the location of the moons, the stars. As time progressed, some of the instruments such as compass, chronometer, theodolite came into the scene. And in the 20th century, electronics entered in the field of aviation. Direction finders and other navigation aids enable the navigators to obtain fixes, that is, exact locations, using electronic aids. Hence, these aids became more and more popular and came into extensive use, and these aids are called the radio navigation aids. These aids help to obtain the magnetic heading and the relative magnetic bearing with respect to the radio station, and thus obtain specific fixes of the object and determine its location on the surface of the Earth. Let us look at the classification of radio navigation aids. Radio navigation aids can be classified in different ways, and this classification helps in understanding the usefulness of a given facility. And the navigation aids which uses radio waves are called non-visual aids. According to service range or the range it serves or the range it helps to determine where the object is present, the radio navigation aids are classified into three broad categories: long range, short range, and medium range. The words itself are self-explanatory. Firstly, let us look at long range navigation aids. Some of the aids operating worldwide in this category are Omega and LORAN. LORAN stands for Long Range Aid to Navigation. They operate in very low frequency, that is 10 kHz, and low frequency, that is 50 to 100 kHz and 100 to 200 kHz band of frequency spectrum to give very long ranges of the order of 7,000 and 700 km respectively. So as you see, the decrease with lower frequency it travels larger distance, and with higher frequency it travels lower distance. But this long range navigation aids, it helps in covering longer distance as a whole. Next is the medium range navigation aids. The non-directional beacon falls in this category of medium range navigation aid. It often operates in low frequency or medium frequency band with a nominal range of 150 to 250 nautical miles and even up to 350 nautical miles over high seas. The next is short range navigation aids. Some of the important and widely used short range navigation aids are VHF, direction finder, VOR, DME, ILS, and radars. As you can see, these are the aids that are used closer to the airport in order to guide the aircraft. So you can understand these are short range navigation aids, but they have a shorter range, but they operate on higher frequency bands. These aids operate in and above VHF bands, and hence the coverage is dependent on the line of sight phenomenon. Coming back to the use of radar in airports and in particularly by the air traffic control. Radar are employed throughout the world for the purpose of safe controlling of air traffic en route and in the vicinity of the airports. Radars as well as vehicular traffic at large airports are monitored by means of high-resolution radars. Radar has also been used to guide aircraft to safe land even in bad weathers when there is nil visibility. The controller no longer needs to depend on the position reports of the aircraft. The controller is now able to see and identify the aircraft and by transmitting suitable instructions can guide the aircraft to keep it clear of nearby aircraft and even to an extent that it can help it prevent adverse weather conditions. Like you can see here, this is the radar antenna transmitting and receiving signals from the aircraft, and these signals are processed and are seen by the air traffic controller on their screens. Looking at these screens, even though they do not have the sight of the aircraft, the ATC controller controls this flight, maintains required separation and obtains required information of the aircraft in order to ensure safe paths for the aircraft. Let us look at the types of radar. Firstly, the Aerodrome Surface Control Radar. It is also known as the Airport Surface Movement Indicator (ASMI) and the Airport Surface Detection Equipment (ASDE) or the Surface Movement Radar. As you can see in this image, this is what a surface movement radar looks like. You may have spotted this at various airports. Here, the radar scans the airfield and draws a realistic map of the airfield on the scope, on which moving and stationary targets are identified. This radar scans the airfield and draws a realistic map of the airport like you can see here. And on this, the mobile and stationary objects can be identified like you can see. In this image, this particular aircraft has landed on the runway or is about to take off from the runway and it can be identified on the radar screen. Further, it is an aid for maintaining separation between aircraft taxiing, takeoff, landing when the controller may not be able to actually see the aircraft maneuvering on the apron or on the runway or the ground due to poor visibility. Moving on, let us look at the Precision Approach Radar. As the name suggests, it helps the aircraft make approaches precisely. It is a component of the Ground Control Approaches System or the GCA system. This radar is used to guide an aircraft for a safe landing. It is designed to accurately determine the range from touchdown, that means the distance from the touchdown, bearing with respect to the extended centerline of the runway. That means at what angle it is with respect to the extended centerline. Further, it also helps to determine the glide angle of the aircraft on the final approach to land. It helps us understand at what angle is the aircraft with respect to the determined glide path while it is on its approach or final approach to land. This radar can be used to cross-check the performance of instrument landing system because it provides the azimuth with respect to the extended centerline and also the elevation of the aircraft with reference to the determined glide angle. We have seen the aircraft on ground using surface movement radar, the aircraft on approach using the precision approach radar. Now let us look at Airport Surveillance Radar or the ASR. It is also called the Terminal Approach Radar. It is a short-range radar with a maximum range of about 60 nautical miles. This radar continuously scans the airspace around the radar site and is used for terminal control. Terminal control means it is used for guiding the aircraft from initial approach point on the extended centerline of the runway to the final approach point. In conjunction with the Precision Approach Radar, it forms the Ground Controlled Approaches System, which means the ASR guides the aircraft initial approach to final approach and then the Precision Approach Radar guides the aircraft from final approach to the touchdown, and together this forms the Ground Controlled Approaches. In order to protect the radar from any interference from other signals or interference due to objects present nearby, no building or structure or object is permitted to be erected within 305 meters radius of the antenna and above an angle of 0.5 degrees beyond this. Now let us look at Air Route Surveillance Radar or ARSR. It is a long-range radar with a maximum range of about 200 nautical miles. The main purpose of this radar is to monitor the air traffic in Area Control Center. In order to protect this radar, no object should be erected 310 meters radius from the antenna and above an height of 0.5 degrees beyond this. And this radar is used in the area control Now let us look at the secondary surveillance radar, or the SSR. It is a secondary radar. Like we discussed in the part 1 of the video, the secondary radar involves active involvement of the object. The aircraft carrying a transponder replies to the suitably coded interrogation signal sent by these particular antenna present on the ground. From the transponder replies, it is possible to extract exact information like the aircraft call sign, the altitude, originating point, destination point, etc. And using this information, the ATC gets particular details of the aircraft and ensures safe navigation of the aircraft. So with this, we come to the end of the video on radars, where we have discussed the major kinds of radar you spot at an airport. The surface movement radar guiding aircrafts on ground. Precision approach radar guiding aircrafts from final approach to the touchdown. And this radar is also used to test the performance of instrument landing system. We have also understood the use of airport surveillance radar, which is also called the terminal approach radar, which is used to guide the aircraft from final approach to initial approach. Next, we have understood the role of air route surveillance radar, which is used in area control. And after all of this, we have understood the role of secondary surveillance radar, which is based on the secondary radar principle. I hope you enjoyed this video on radar and you have understood what kind of radars are specifically used at an airport and what are its usage. I hope next time you spot a radar around the airport, you can identify which one it is. If you have not watched part 1 of the video, do click on the link given in the description to watch part 1 of the video on radars. This is Aviation Avi, go where you feel the most alive. This presentation was prepared by Shantanu and I am Anvesha presenting it to you. Do not forget to like, share and subscribe because your support is our motivation. In the comment section, let us know what more topics you'd like to watch on Aviation Avi so that we can make more such informative content for you.